Hello, everyone. Welcome to my channel. Today, we'll be discussing this very interesting topic that is based on mensuration. When it comes to mensuration, there are two types of questions that you can expect in your exam. Either the shapes are going to be based on 2D shapes, or you might come across a question that's based on a 3D shape. And you should be very well familiar as to what kind of 2D shapes can be tested. In this lesson, we'll just be discussing 2D shapes. In the next video, I'll discuss the 3D shapes as well. Now, whenever it comes to these 2D shapes, we have a rectangle, we have a triangle, we have a parallelogram, similarly trapezium, and then of course we have circles and slash sector. That's basically a part of circle. We'll also be discussing this. What you need to realize over here is that these types of shapes, the question is only going to ask you to figure out the area or the perimeter. A lot of students get confused. What about volume? Volume doesn't exist for 2D shapes. The word volume only exists for 3D shape. So when you come across a 2D shape, just bear this in mind, you can't have volume of triangle or volume of rectangle. It's not possible. There's only one thing that's known as area, or they might ask you to figure out the perimeter. A lot of students also get confused with the word surface area. Again, generally, when it comes to 2D shape, surface area is the same thing as area. But when it comes to 3D shape, then of course, we have to take into account all the shapes we have. And that is how we say that's the surface area or the total surface area or the curved surface area. Again, we'll discuss these fancy words probably in the next video. Right now, I just want you to make sure that you have that rudimentary understanding on how these shapes work. And I'm pretty sure you're already well equipped as to how a rectangle looks like. I've written this as length, width, height, whatever you want to take it. These symbols, they don't have any meaning at the end of the day. And I've written down the formula for area, and I'm pretty sure my entire audience probably knows area of a rectangle is length into width. In a similar way, when I say the word perimeter, that means you add all the exterior sides. So I can say that's going to be 2L plus 2W. If I scroll down, we have a trapezium. Now, there are two types of trapezium that I've drawn, and you should understand that in your exam syllabus, both of them in IGCSE and O-levels are included. The first one is what we call as an isosceles trapezium. And the second one is what we call as a non-isosceles, or more often we say it's a right-angled trapezium, right-angled trapezium. And the formula for both of them stays the same. So these arrowheads that I pointed out, that means those sides are my parallel sides. The formula says area equals to 1/2 times sum of parallel sides times height. Now, when I say the word height, you need to understand that in this case, it's going to be the perpendicular height, the one that is forming over here. This height is known as the slant height. And they might ask you in a question to figure this out, and obviously we'll discuss on how that works. What you need to realize over here is that in this formula, you'll take this. But when I ask you to figure out the perimeter, then you will, of course, take all the exterior sides, not the inner one. So kind of know this difference, when it comes to height, what's perpendicular height and when I say the word perpendicular, that means there's a 90 that's forming. That's the reason why we say it's times perpendicular height. So I hope you understand why that word exists. If I keep scrolling, now we come across the three types of triangles that are actually in your exam. I would say more often the first two. I wouldn't say scalene. I've rarely seen instances of scalene triangle in mensuration. Yes, in trigonometry, that's the case, but we're not discussing trigonometry. We're discussing mensuration. So anyways, when it comes to an isosceles triangle, you need to understand that an isosceles triangle is something that has two sides and two angles equal as well. And as you can see, the area of a triangle is 1/2 base times perpendicular height. Again, when I say the word perpendicular height, that means it has to be this one. And what do you call this? That's a slant height. In a similar way, we have the same for equilateral as well. The word equilateral means all sides are equal, all angles are equal. And similarly, we have scalene. The word scalene means none of the angles are equal and none of the sides are the same. That means maybe this side was 4, this side is 5, this side is 6. I don't know, this angle could be 30, this could be 40, this might be 110. So all angles are different, all sides are different. That's how we define a scalene triangle. Now, I would say most often you'll come across isosceles. At least in my experience, I've seen this. In IGCSE, in O levels, you'll see majority of the questions are going to revolve around isosceles triangle. Now, let's take an example. So let's say this is an isosceles triangle, and I'm just kind of giving you the instance as to how this kind of question can show up. Let's assume this side is how we define as the slant height, this one, the curved, the diagonal. And I'm telling you the base over here is 6. And the perpendicular height, what does that mean? This height, or you can also label this outside, doesn't matter. I'm saying that this is 4. When I say the word perpendicular height, that means when it comes to an isosceles, you can break down an isosceles in 2 equal halves. So in other words, I'm just saying that if I were to make this line, I can say that there's going to be a triangle on both sides. There's going to be, this is a right angle triangle, and similarly, this has a right angle triangle. We can just take one of them. And if that's the case, then this side of 6, the base has 6, is also going to divide into equal halves. That means this is also going to be 3. So if my question says to please figure out the slant height, you can now use Pythagoras. Because if you remember that trigonometry video that I uploaded, I said whenever you see 90 in life, what does that mean? Either SOHCAHTOA or Pythagoras. Since they're asking us the side, that's the reason why I chose to use Pythagoras. So I can say that my slant height is going to be L squared is equal to, or hypotenuse squared equals to, base squared plus perpendicular squared. If you add this up, that's going to be 9 plus 16, square root that, and you end up getting 5 as the answer. I get this question, isn't that going to be plus minus 5? When it comes to a triangle, when it comes to a side, please use some common sense. It's always going to be plus 5. You can't have a side that's negative 5. So again, this is how, or one of the types of question could show up in the exam. There's also another shape that is mostly neglected, I would say, and I think many students, they don't really focus on this shape, that is a parallelogram. The word parallelogram means opposite sides are equal and they're parallel. When I say the word parallel, that means they're moving in the same direction. When I say they're equal, that means they're equal in length. So let's say if this side was 5, without a doubt, this is also going to be 5. Similarly, this is going to be, let's say 3, then this also has to be 3. So kind of, as in I would expect should know this. But the area is something I have seen many students struggling with. So the area of a parallelogram is exactly similar to what we have for a rectangle. We can say that's going to be base or length. I've seen many students, they get confused. Isn't that length into it? Isn't that blah, blah, blah? Doesn't matter. At the end of the day, it's just one of the sides that I'm talking about. So right now, I'm just saying that's base, and that's my perpendicular height. Keep that in mind. Not the slant height, the perpendicular height. I hope you're kind of getting familiar with the jargon and the vocabulary that I'm using. Most of the students, and they think that this shape is not included in the syllabus. And I can actually prove this to you. So if I were to scroll down, you'll see that I have taken a screenshot of your syllabus. Again, this is applicable to IGCSE and O levels starting from 2025 onwards. You can see the very first part over here. It says carry out calculations involving the perimeter. I haven't written down the formula for perimeter because I would expect you should be able to improvise. Add all sides. I hope I don't need to write it down that, oh, if this is 5, this is 5, that's 3, and this. You should know that you have to count all the sides and add this up. So I'm not writing down the formula for perimeter, and I expect you to be smart about it. The same goes for isosceles triangle as well. If I ask you what's going to be the perimeter of this, think we just knew that my slant height came out as 5. Can I say if this is 5, then this also has to be 5? Because like I said, these two sides are the same. And the base is 6, not 3. So can't you say the perimeter is going to be 5 plus 5 plus 6? This ends up giving you 16. That's it. So I would expect that you should be able to figure this out. I hope I don't need to write down the formula. Oh, that's going to be L plus L plus. That's just too much work. I can't do that. So, and it keeps changing, so kind of depends on the question. But anyways, just wanted to make sure that you kind of go over this. And the reason I wrote down the formulas is because of the fact that these formulas are not given to you except a triangle. So it even says that over here as well, except for the area of a triangle, formulas are not given. That means they would expect that you should know the area of a parallelogram, you should know the area of a trapezium. The second kind of shape that we have is, of course, known as a circle. And if I were to draw a circle, and I'm pretty sure all of you are well equipped as to how it looks. This is a circle. Again, there are only two formulas that you should be familiar with, and that is area equals to pi r squared. What does the word radius means? Something that starts from the center and till the circumference. So the second formula is known as circumference, which is 2 pi r. What I want you to understand, if I ask you to figure out the perimeter, so perimeter is the same thing as circumference in a circle. So don't get confused. I think I saw this one question, IGCSE, if I'm not mistaken. I don't exactly recall the year, but it said, find the perimeter. And I saw so many students complaining about, we don't know the perimeter. Well, you do. It's circumference. So this ring over here means that you're adding all this side. And what's the formula for that? 2 pi r. Now, there's another, weird shape that we have that is known as a sector. Now, this itself is a different topic, but I just wanted to make sure that I should teach this in the same video. Because at the end of the day, it is a 2D shape. So when it comes to a sector, please bear this in mind. A sector is an area, I'm going to write it down. It's an area that is bounded by two radii. When I say the word radii, that means it's plural. Radius is singular. So let's say this is the center of the circle. And let's assume that's my radius. And this is also my radius. What you need to realize over here is I have now made a sector. That looks like a slice of pizza. And that's right. So in other words, if that kind of helps you to understand, you should know that a sector is always going to be a slice. It could be a bigger slice. It could be a smaller slice. Doesn't matter. At the end of the day, it's just going to be a slice. So the area of this, what is a sector? I just said sector is a part of the circle, right? I made the circle and I just chopped off a slice. So the formula stays pretty much the same. So what's the area of a circle? We just did this, pi r squared. So pi r squared, you just multiply this with theta over 360. In other words, I'm just saying take out this angle, divide it by 360 and times it by pi r squared. The same applies for arc length as well. What is this word? Arc is something that's drawn with a compass. And you can see that this is an arc. So I'm just saying the length of this arc is what we call as arc length. Kind of makes sense. What is this? Isn't that the perimeter? What's the perimeter of a circle? Circumference. Excellent. And what's the circumference of a circle? 2 pi r. Genius. So I know that I also have to kind of multiply this by the same angle by the 360. That's pretty much it. So guys, what you need to realize over here is that this angle that I'm taking, when it comes to angle, there are two units. The first one is known as degrees. And the symbol that we use is 70, and then we place this tiny dot. And there's another type of angle which is known as radians. And for that, we use the unit rad. So I can say 3 pi rad. This is not a part of O levels and IGCSE. This is definitely part of AdMaths. So for those of you taking AdMaths, they would probably know what I'm doing, but just a heads up, there's one small request. Please make sure when you're doing a question based on a sector, your calculators should have that D written on top. That means it's in degrees. So kind of make sure you don't make the mistake, that I get to see most often. So anyways, the formula, of course, is a little different as well in AdMaths. It's pretty much the same, but obviously it's in radians. That's the reason why it looks different, but honestly, it's the same. So that's me discussing all the relevant, important 2D shapes. I think we've done enough chat, and now we can just jump on to questions. So let's have a look. Again, this is a weird question. I know you're probably thinking, what the hell is this? Calm down. It's not a big thing. Let's discuss it. So in this case over here, I know this side is how much? 25. Let's kind of make this go down. So I can say, well, this is 25. And how much is this? 5. So can I say the total length? Can you raise this? And I can just say, well, the total length of this side will be 30. How did I get this 30? Well, I just told you 25 plus 5. So I'm just kind of adding this and this. In a similar way, we know this entire side is 20. So can I say if this is 5, this is 12, what does this account to? 5 plus 12, that's going to be 17. What more should I add to make this 20? Can I say that's going to be 3? That means this is going to be 3. This tiny side is going to be 3. So did I not just say that if you want to figure out, so right now I'm just figuring out the unknown sides. So if this whole thing is 30, and I know that means this whole thing is also going to be 30. If that is the case, how much do we have already? 10. So what more should I add? 20. Right? Think about it. 20 plus 10 is 30. So if I were to move this up, you probably would now understand that's how it looks. So I'm not doing anything fancy. I'm just trying to figure out the unknown sides. Why? Because I need to figure out the perimeter. What does the word perimeter mean? Add all the sides. I said improvise. There's no formula that I can teach you for this kind of weird shape. So let's start from this side. 20, done, plus 20, done, plus 5, done, plus 10, done, 12, plus, I'm going this way, 25, plus 3, plus 5. Let's add this up. That's going to be 40, that's going to be 50, 75, 80. This would be 95, and that's going to be 100. So this comes out to be 100. Please bear this in mind. This is a paper 1 question. That means a calculator is not allowed. If this comes in your exam, this might be worth 2 marks because this is an old past paper, and you do realize the new exam structure says that now it's going to be 100 marks for almost or approximated 25 questions. So they have to balance out the marks. So I'm just saying there's a good probability this might show up as a 2 or 3 mark. Maximum 3, wouldn't go beyond 3. The next part says to figure out area. Now, when it comes to this kind of weird shape, I can't tell you the formula for area, and you can make this up on your own. So it kind of depends on how you want to break this down. I can divide this shape into pieces. I can say, well, you know what? Guess what? This is a rectangle. Similarly, this is also a rectangle. Let's give this a different color. And this tiny part is also a different rectangle. So what's the area of a rectangle? Length into width. I know this side is 10. I know this side is 12. So can I say the area of this is going to be 120? So we can, just doing this, you don't need to write this down inside. I would expect that you show this working over here. I would expect that you write down 10 times 12, and that gives you 120. You can call this A1 if that helps. In a similar way, this side is 20. And what is this side? You might think it's 20. Wrong. This whole thing was 20. If I subtract 3 from this, I know that's going to be 17. Can I say that? If I were to erase this mess, this whole thing, the length till the bottom is something that's worth, what do you call it? 20. And we know 3 is not a part of that. So I can say, well, this part over here is 17. So that's a rectangle as well. I can say, well, in this case, area 2 is going to be 17 times 20. 17 times 2 is 34. So that's going to be 340. And finally, the area 3, which is the small one, I can say, well, that's going to be 5 times 3, which gives you 15. So let's add this up. Can I not say that if I were to add all the exterior areas over here, or total area over here, would it not be 340 plus 120 plus 15? That's going to be 460 plus 15. That should come out to be 475. Do they expect us to make this calculation without a calculator? Hell yeah. And I expect you to be smart. You see, this is the way I have broken down. You could have broken it down in this rectangle as well. Maybe this, whatever works out for you. It doesn't matter, but make sure that you don't take the wrong sides. So that's all I have to say. I think this question was easy. I don't think this was hard. Now let's move on to another question. The question over here says the diagram shows the trapezium with length, blah, blah, blah. Find the area of the trapezium. What's the area of the trapezium? All of you, I want you to cheat. We just said area equals to 1 over 2 times sum of parallel sides times height. Can't you say if that is the case? Well, in this case, that's going to be 1 over 2 times the parallel sides, which should be b plus 4b, and the height that is 12. Again, this is also paper 1. I can say the area is 120. So let's kind of simplify this. 2 times 12 is, of course, 6. I know that's going to be 5b inside the bracket. Then we have 6, and then we have 120. I can throw this in the denominator, or I can put this in the denominator. That should be 20 is equal to 5b. So again, b comes out to be 4. Honestly, I think this is not challenging. I think this is quite easy, and you should not struggle in plugging in the formulas. There's literally nothing that's too complicated. Now, we move on to something that's based on arc length. So for those of you who did request this topic, I've already gone over the formula, but now I just need to kind of make my work around this question. So what's the area of a sector? So here's what we established. We established that a sector is basically a pizza slice. And if that's the case, then we know the area of a sector is theta over 360 times pi r squared. There's only one small request. The area of a circle is given, but the area of a sector is not given in the formula sheet. So please, guys, I beg you, don't mix this up with circumference, because I have seen some students writing it down as 2 pi r. That's wrong. So anyways, now let's kind of focus on what the question says. It says, the diagram shows the metal cover for a circular drain. All right, water drains through the shaded sections. I'm sure you might have seen this somewhere. O is the center of the circle, and they've given us the radii. So it says the first one is 1 centimeter. The second one is, of course, 2 centimeter. The third one is 3 centimeters. The last one is 4. So kind of makes sense. You do realize that they're just saying that this is a circle, and they've given us the diameter. So they're saying the first circle over here has the radius of 1. The second circle has the radius of 2. The third circle has the radius of 4. The fourth circle has a radius of 1. Okay, so 1, 2, 3, 4, and yeah, and the bigger one is the 5. So they've given us the circle areas, for all of them. It says calculate the area of the shaded section ABCD. So this is A. This point is A. I've seen many students considering this as A. Are you crazy? A is a point. It's a small point over here. This is the kind of area they want. My question to you is, what is this? That's a weird shape. Is it possible for me to figure out the area of this thing? Let's first figure out the area of this. So all I'm asking is for you to figure out the area of this. Now, guys, what you need to realize over here is that they've given us the angle as well. They've given us that this is 40 degrees. Inside, we have 40 degrees. Listen to me carefully. The first one had radius of 1. The second one had radius of 2. The third one had 3. The fourth one had 4. So right now, we are dealing with the radius, which is 4. If that is the case, let's plug this in. 40 over 360 times pi, and then we have 4 squared. It says giving your answer in terms of pi. Just a heads up, you don't need to simplify this. You have to simplify all these other numbers. There's one more thing that I'd like to also emphasize over here, and that is this question is also a P1. And trust me, these kind of calculations, they're not hard. It's just that you have to think a little more, I would say, carefully. So again, 4 and 4, 0 and 0 cancels out. I know 4 times 9 is 36. I would expect that you should know basic multiplication. So I can simplify this. I know 4 times 9 is 36. So I can write it down as 1 over 9 pi, and then we have 16. 4 squared is 16. So maybe I can write down the answer as 16 over 9 pi. You can't simplify this. You can't simplify this. What does that show us? Let's kind of shade that region. So right now, what we just figured out is this whole thing. Is that what the question wanted? No, the question only wants this, just the top part, not the whole sector. So is it possible for me to figure out is it possible for me to figure out this sector as well? Yeah. Again, what's the area? What's the radius for this? So first task is to identify which radius are we going to use. So for the previous one till C, we used 4. Again, I said the first circle is 1, second circle is 2, third circle is 3. So can I say now the radius is 3? Angle stays the same. It's still the same angle. So again, if I were to use this, I can say this is, again, we can call it area 1 if you want, and then we can figure out area 2. So again, that's going to be, again, 40 over 360 times pi, but now we have 3 squared. That's going to be 9. I can plug this in and then simplify, or I can just calculate this. Doesn't matter. 0 and 0 cancels out. You end up getting 1 over 9, and then it's going to be pi 9. This and this cancels out. You end up getting just pi. What does this represent? Pi. And what did the previous part represent? This whole thing. We knew this came out as 16 over 9 pi. So if I were to figure out just this, don't you think I should subtract the bigger area, which is this, minus this? So I can say, well, area of ABCD is equal to 16 over 9 pi minus pi. I expect at this point in time, you should know how to take the LCM. That's going to be 9. That's going to be 9. If you try simplifying this, that should give you 7 pi over 9. This is the answer that you get, and that's it. It says giving your answer in terms of pi. Are we not supposed to divide this? Never divide this in paper 1 unless you hate yourself. So we need the answer in a fraction, and that's perfectly fine. Anyways, that's how it works. There's one more question that I would like to solve. And it's this one. On a scale of 1 to 10, I would say this question is a perfect 10. So listen to me very carefully. Find the perimeter of the shape below. I want you to pause this video, and I want you to try this on your own. If you can solve this, trust me, you're a genius and you've already mastered 2D shapes. You have mastered how to figure out the perimeter, and I respect that. If not, then, I would expect now you watch. Anyways, so in this case over here, I know this whole side is 4. The problem over here is, how do I figure this out? I mean, yes, I know this thing is going to be 4. There's no doubt. But how does that help? In a similar way, I know this whole thing is 6. And this is going to be 6 as well. Sure. But like I said, how does it help? So if you couldn't solve this, now let's have a look. This is 1, and I can say this is also going to be 1. What you need to realize over here is that if I were to count this, now I said this whole thing is 6. Can I say that means this thing and this thing? If I were to add these two sides, they should give you 6. Excellent. In a similar way, I know on the left side, if I should add this and I should add this whole thing, that came out as 4. So that means this and this, which again, I can bring this over here, this should be equal to 4. So I'm kind of labeling this out. The green side, the whole green, is equal to 4. That means this and this tiny part, because I know opposite sides are equal. In a similar way, I know the blue side and this blue side is also equal to 6. And finally, I know in this case, this side, and this side. What does that equal to? Just kind of bring it up. That's also going to be 6. That means I have figured out all the sides. What's the perimeter going to be? Let's start from the easiest side. Let's start from this. That's going to be 4. Done. Plus, what about this? I just said blue side is going to be 6. That means this thing and this thing. Plus 6. What about this green side? All of green is going to be 4. That means I'm also done with this. I'm done with this. I'm done with this side. How about the blue thing first? So we know the blue is equal to 6 because we knew this came out as 6. And then what about these red boxes? Because we know we have to add all the sides. So that's 1 and that's 1. So plus 1, plus 1. If you add this up, that's going to be 22. And that's my answer for this. Again, this is O-levels, and this is based on something that came out a couple of years ago. But this question is an amazing question. And if you understood this, then hopefully you understood the very basics of compound shape. With this, everyone, we wrap it up and we'll catch up again in the next video where we will cover up mensuration in 3D shapes. Till then, adios.